Hello, I'm Roman, and welcome back to the series of the videos Neural Networks from Scratch in Golang, where we're using the book called Neural Networks from Scratch in Python, but we're writing everything with the Golang. And I am at chapter 19, a real dataset. So I'm going to actually test what I wrote before with the batch processing. So I just wrote all of the code, and right now actually I will commit this and we will try to use this. The main change was inside model train method. So we introduced working with the slices. Well, I introduced working, loading, taking the data for the training in steps. Yeah. Batch training. Spelled like this, right? And let's try. So the next thing will be actually trying to implement the model and why don't optimize category cross entropy loss doesn't implement calculate accumulated loss. Okay, optimize this one, right? The loss. Calculated, I think, and then loss, right? Calculate, accumulate, and it returns loss 64. Okay, so I don't like it. What else is missing? Calculate accumulated loss. Okay. Optimize categorical cross entropy loss. Wait. Optimized categorical cross entropy loss. Calculate accumulated. Accumulated loss. First. Optimize. Calculate accumulated loss. Okay, so basically I need to take this one and insert here. Okay. So this one is fixed. So what we're going to run, I'm going to implement fashion model. So models. Okay. How I usually do this, just run. Okay. Func run fashion model. Called like this. So first we need to take X and Y from dataset fashion. Basically, DS is dataset, fashion is dataset, right? And X and Y we take DS training dataset and val X, val Y validation, DS testing dataset. So far so good. Then shuffle training dataset, but I already returned it in a shuffled way, right? Yes. So this is where I shuffle it. Scaled and reshaped already. Then construct our model consisting of two hidden layers using relo activation and output layer with the softmax activation function. Since we're building a classification model, cross entropy loss, atom optimizer, and categorical accuracy. Okay. So let's do so. We have the model. We have model.model, right? Then maybe I should, okay, model. Oh, and we need to take shape number of the calls. Okay, taking num inputs. Wait, num inputs equals to x dims, right? So then we add and we use a layer dot layer, and then we initialize number of the imports. Num inputs. How many neurons? 64. Really? Oh, there is an error. Okay. Error, right? And error equal to nil, then log error. And same here. So should I return? Oh, it's all the OS exit. Okay. From the model, add layer. Oh no, that's activation random. The first one, and we have the same. No, second. This one will be a 64 by 64, and we have activation. And the last one, we have the 10, and here we activate softmax activation, right? Okay, then we create a loss optimizer, and okay, so we have optimizer new atom, right? Then we change the decay to the value of 5 minus 5. Okay, and set loss categorical cross entropy loss, right? Then we have the optimizer, and then we have accuracy, which accuracy categorical, right? Categorical accuracy. Cannot you? Why? Okay. Get the okay. Class categorical percent class get the inputs at the that's strange. I have the D inputs and real? Interesting why it's not in the base loss. Categorical percent per loss. Declared but not used. Okay. Finally, we can finalize and train. Finalize and then train. Model data X and Y. Right? Epochs. 5 epochs. Batch size 128. Print every 100. And model X file. Cannot use. Okay. Batch size and then batch size. Cannot use xval as the maintenance value in the struct literal. What? Understand. Training data model data x y. Okay, so we're ready to run and wish me luck. I think it won't work. Make run. Okay, it loads the data. 2. Okay. Interesting what it means. Of course, I didn't change it. Models run fashion model. Dimension mismatch. Okay. Fashion main run. When exactly? Train forward. Okay, so on the multiplication, there is a mismatch. Okay. I think on the first one, right? Okay. I'm going to debug it now. What happened? How many training steps? Okay. Okay. Reset. Batch X, batch Y. And 28. Okay, so what's the size of so you want to tell me that it should be like this? Dense layer. Okay, still the same. Okay, so I assume this is correct. Okay. Batch. Okay, we're going to forward. And we have input. No, okay, we just, yeah, this one we just copy. Okay. inputs 128.7. How many rows do we have? Wait. Hash. Okay. Okay, number of the inputs 784. Okay. Okay, we have 128. Why 64 columns? At which point I get the 64 values? Okay. Maybe batch X? No, batch X is correct. What is the input? Input is correct, right? So the input layer gets output. And what's the output here? So far, so good. Okay. Then we go here, right? Oh, wait. This is weird. Okay. Okay, forward. The first thing we call forward on the input layer, which will just store the output. Okay, then we go for the first one and we call in forward. Call in forward. So this one returns from the input layer. Okay, so that's correct. Then we call forward. Okay, so this is for the first one. So the first one should be 128 in the rows and 64 in the columns, right? Right. Okay. That's correct. Then we go for the second one and we take in the output from the first layer. And where we are. Okay. And call forward for the second one. So the next one should be, oh, this is the activation one. Okay. It's the activation one, right? Then we go for the third layer, right? That should be dense. Oh, activation 64 by, no, 128. Same. Okay, then we go in for this one. We have the inputs. Yes, okay. Number of the rows, 64. Okay. Softmax activation function. Okay, so go inside by 10. Call forward. Okay, this is the forward for the softmax. All right. Okay, so 122 by 10. This is expected, basically, because I have the 10 outputs and 128. Okay, then okay. Data loss calculates, regularization loss calculates, loss value calculates. Maybe predictions, maybe the accuracy, maybe this one, maybe the backward methods. No, maybe this one. Index out of range. Yeah, I think this is the one. I think the index out of range happens here. Right. Okay, rows and rows and row. Row index equals to target row index equals to step plus 1 batch size, right? If target row index bigger than rows. Target row index equals to rows minus 1. Target row index. Target row index. Let's try. Okay, so I need to do the same for the validation. Where is it? Yeah, I will need to do some refactoring this to make it, a little bit prettier, but I will talk about this later. Interesting, I have the non-accuracy for the last one. Okay, I need to check this. Index out of the range again. Model 200. Okay, so this is for the validation, right? So right, because it's xval and well, yeah, there are some code duplicates that I can move out. Okay, what do they have? This was done with a new real, much more challenging dataset in just 5 epochs instead of 10k. Training also went faster than with our previous attempts at spiral data when we trained by fitting the whole dataset all at once. Okay, I have a small accuracy and I have, small loss. I need to understand why I have none. That's weird. For the accuracy, where calculate accumulated accuracy. What accuracy I'm using? I have using categorical accuracy. I have it in the base one. Oh, I'm not using it accumulated. That's the issue. Wait. Categorical. Okay. The problem that I do not call It's accumulated accuracy. This is the, where it was. That should be in the accuracy calculation, right? Calculate the and accumulated. Okay, so accuracy at accumulated. Wait. Really? Wait. I had the accumulated loss, right? Plot sum len. Okay, so that should be plot sum comparisons, right? And len of comparisons, right? Cannot use len in 64. Okay, for range for comparisons for in the range of comparisons. Row sum equal to 0 and if v sum plus equal 1, right? Okay. It should show the accuracy right now, right? Interesting that it's not crashing when there is a division by 0. No exceptions. Okay, yeah, I have the accuracy right now. That's good. Then again, we can see that we end on, I guess we'll have the big loss and yeah. Validation loss 0.4 accuracy, 85%. I mean, it works. As we can see, that doesn't work well at all. We can observe how this model approached the perfect accuracy of 1 during training, but epoch accuracy remains poor and the validation accuracy proved that the model did not learn. Training accuracy quickly became high since the model learn to predict just one label. Once the label changed and trained it, the model quickly learn to predict only the new label. I think that I think that's the place where it jumps, right? In the case of validation, the label that model predicted was the last label it had seen. Its accuracy was close to. Okay. Re-enable and shuffle, and then you can think around with your model to see if you can further improve results. Here's an example with a larger model, a higher learning rate decay, and twice as many epochs. Okay. The passion, what we'll do. 128. So we basically will change all 64 by okay. Higher learning rate or decay. Okay. What? And twice many. Wait, twice bigger. Yes. 10. I think that will take a long time to train. Okay. We'll wait some time. We improved accuracy and decreased loss a bit by simply increasing the model size, decays, number of epochs. Okay. I will take a look. This is the whole code. Model evaluation. Okay, while it's training, I'm going to commit all of the files. What is it? Batch training is done, basically. I will name the same. Okay, so there's 7 epochs. I wouldn't say, well, training accuracy 88%. It's an average accuracy, right? 88%. Okay, so we have the accuracy 89%. Oh, 87%. Slower, simpler, smaller loss. And yeah, basically right now I have a model that could train on the batches. Ideally, I should not load all of the data into the memory. As I understand, training in the batches improves training speed, and especially with the shuffling of the data. But for example, in order to make the further optimizations, I don't have to load all of the batches into the memory at the same time. So we can, load 128 images into the memory, train, then unload them, load once again. And this is how I can increase size of the data set like 10, 100 bigger, and it still will work the same. But probably I will implement this later. But for now, I think this is the good stop point. And look, I'm kind of model evaluation, save, prediction, inference. So I'm very, very close to the ending of the series. It's like less than 70 pages. So probably looks like there is a possibility that I will finish it maybe in just 2 weeks. And I will finally record a video about this. Okay? Thank you for watching, and I see you tomorrow. Bye-bye.